Today's lesson will be tricopter frames, that is, drones with 3 arms. We will examine them under 6 headings. These are the general features, advantages, disadvantages, configuration types, usage areas, and performance summary of tricopters. Tricopters are generally known as 3-arm and 3-motor drones. They can be easily transported thanks to their light structure. They have software differences because they have 3 motors. The advantages are as follows. It is more efficient with its lightweight design feature and requires less material than quadcopters. Since one less engine is used compared to the quadcopter, it has become a less costly and less power-consuming drone. Since it consumes less power, we get a longer flight time. The servo motor, attached to the last engine, provides precise directional control and agility. The disadvantages are, since we use 3 motors, it is less stable than a quadcopter. Flying it in windy or harsh weather conditions may be dangerous. In addition, since it has 3 engines, it carries less load and can fall directly in case of any engine loss. Among the disadvantages, some mechanical problems arise because we need to make a different connection point because we need an additional servo, and this point creates the possibility of malfunction. Additionally, some software problems may arise because open-source software may not support the tricopter, and since we add a servo, it requires an advanced control card. Our current topic is configuration types. First, let's start with the design with 3 motors and 1 servo. There are 3 arms, 3 motors, 1 servo, and the difference between these motors is 120 degrees. The servo we added is connected to the last motor and enables the yaw movement. The other design has similar features, but the main difference in this one is that there is no servo and it contains 4 motors. This 4th motor we mentioned is connected to the other motor up and down, thus we can prevent the gyroscopic effect. If we talk about the areas of use, we can use it in hobby activities, low-scale experimental projects, and educational activities. In the performance summary under the same conditions, you can compare the tricopter with a quadcopter according to the information given below. For example, you can see that the values such as lift force and flight time are different between the two. On this page, you see the continuation of the comparison. As a final performance summary, tricopters stand out with their long flight time, lightness, and economy, while quadcopters were developed for professional use and more payload carrying capacity. In our lesson, we gave detailed information about tricopters and compared them with quadcopters. Here the choice between the two depends on what the end users want. Thank you for watching the video.